Hello students, welcome to AIMS India online classes. This is a chemist session. Here we are discussing about chemical bonding chapter. In this session we are going to see about the practice sheet related to this chapter. In the earlier sessions we have seen different kinds of chemical bondings and different examples also we have seen on those. Based upon those concepts of ionic bond and covalent bond, even coordinate covalent bond formations, we are going to see a practice sheet now. First, let us go through the conceptual understanding type questions. See the first question. Electrovalency of non-metal atom is not equal to that of the metal atom in. See, in which molecules the electrovalency of non-metal and metal are not equal. We see first one, sodium bromide. In this, sodium electrovalency is 1 because it can donate one electron, so its covalency or electrovalency is 1. Whereas bromine is of halogen group or seventh group. It can accept one electron, so its valence is also 1. That is, electrovalence is 1 for this. If we see for magnesium, it is 2, and for oxygen, it is also 2. For aluminium, we know it is 3, and for nitrogen or nitride ion also, the electrovalency is 3. For potassium, the electrovalency is 1 because it belongs to first A group. If we see for sulfide or sulfide ion, it is 2. Now, if you observe in this, metal ion and non-metallic ion, sulfide ion, both are having different electrovalencies. So, this will be the correct answer. Okay, next one. Cotton is isoelectronic with anion. Sorry, cation is isoelectronic with anion in. See, both should have same number of electrons. We know what is the meaning of isoelectronic. The ions, these ions or atoms or molecules which are having same number of electrons are called isoelectronics. See here, if we see sodium ion in sodium chloride, it has 10 electrons because sodium has 11 electrons, and in the ionic bond formation it loses 1 electron, and hence it remains with 10 electrons. What about chloride ion? We know chlorine atomic number is 17, and the chloride ion has 1 extra electron. Total it is 18. So they are not equal here. If we see in case of potassium chloride, we know potassium atomic number is 19. In the formation of potassium chloride, potassium loses 1 electron, and hence the number of electrons becomes 18 here. And just now we have seen chloride ion will be having 18 electrons. So cation and anion both are having same number of electrons in potassium chloride. So cation and anion are isoelectronic in this case. Okay, this is the correct answer. Okay, and if you see lithium, it will be having 2 electrons. Fluoride ion will be having 8 electrons. Magnesium ion will be having 10 electrons. Bromide ion will be having around 36 electrons. Okay, in these all cases, cation and anion are not isoelectronics. In this case only, both are isoelectronics. Okay, next one. Duplet configuration is not found in. Duplet configuration means having 2 electrons in its first shell, that is outermost shell. See H minus. We know hydrogen has 1 electron. H minus means it gained 1 electron. So it has 2 electrons now. That is a duplet configuration. What about H2 molecule? Each hydrogen atom will be having 1 electron. On bond formation with other hydrogen, both hydrogens will share mutually 1 pair of electrons. So both will get 2 electrons by sharing. So they are having duplet configuration. And lithium, the atomic number of lithium is 3, and it is shown here Li plus, means it lost 1 electron. By the loss of 1 electron, it remained with 2 electrons, which is called duplet configuration. And we see beryllium, atomic number of beryllium is 4, and it is shown here plus 3 symbol, means it lost 3 electrons. Out of 4, it lost 3 electrons, so it is remained with only 1 electron. So existence with 1 electron is not called duplet configuration. Should have 2 electrons in its first shell and that should be the last shell. Then it is called duplet configuration. So these three are having duplet configuration except Be plus 3. So this is the ion which is not having duplet configuration. So the next one. In an ionic crystal, cations and anions are held together by. In an ionic compound, cations and anions will be held together by certain electrostatic force of attraction. Electrostatic force it is called. Okay, because of this, cations and anions are held together and they form ionic crystals. Next, during bond formation, potential energy of the system. So in the after the bond formation, the energy or potential energy of the system will be decreased, and hence the system becomes more stable and least energetic. That's the main purpose of bond formation. Atoms in the form of molecules or crystals, they will tend to least energy and more stability. Thus we can say during the bond formation, potential energy of the system decreases. Energy is lost. Okay. Next, which of the following has a tendency to form covalent bonds? See, which of these can form covalent bond? If you observe, these all elements, beryllium, barium and calcium, all they belong to second A group and sodium belongs to first A group. Mostly these atoms will tend to lose their valence electrons and they will be ready to form ionic bond. But except one of these atoms, that is beryllium. Because of its smaller size, beryllium will show interest in forming covalent bonds instead of losing its two electrons and forming ionic bond. Beryllium will tend to form covalent bonds. That's why it forms always covalent compounds. For example, beryllium fluoride, beryllium chloride. These all are covalent compounds which are formed by the sharing of its electrons, not by transferring of electrons. Whereas the remaining metals, they will lose electrons and will be ready to form ionic bonds, except beryllium. So beryllium forms covalent bond. Okay, next one. Which of the following describes an ionic compound? So here some properties are mentioned. Which property describes a ionic compound? Let us see. Low melting point, low boiling point, high melting point, easily vaporizes. Which will be the property of ionic compound? Ionic compounds are strong solids, hard solids actually. So they'll be having high melting and boiling points. Because of high electrostatic force of attraction between the oppositely charged ions, they are held tightly together. So melting them requires a high and high temperature. So you can say melting and boiling points of ionic compounds are very high. Okay. Next, covalency of carbon atom in carbon dioxide. Covalency in the sense number of electron pairs shared by an atom in the covalent bond formations is called its covalency. We know carbon shares 4 pairs of electrons with 2 oxygen atoms because carbon has 4 valence electrons. So it forms 2 covalent bonds with each oxygen atom and hence totally it is sharing 2 pairs of electrons with each oxygen. So finally it is sharing 4 pairs of electrons with the 2 oxygen atoms. So the number of electron pairs shared by an atom in the covalent bonds formation is called its covalency. So hence we can say the covalency of carbon in carbon dioxide molecule formation is 4. Okay. Next, the bond formed by sharing of electron pair is called, what it is called, covalent bond. The bond formed by the transfer of electrons is called ionic bond. The bond formed by the sharing of electron pair is called covalent bond. Next one, the number of electrons contributed by an atom or the number of covalent bonds formed by an atom is called covalency. Just now I told here. The number of electron pairs shared by an atom in the covalent bonds formation is called its covalency. Okay, covalency is correct answer. It is a definition for covalency actually. Next question. The bond in which both the shared pair of electrons are contributed by one atom only is called. Generally, in the covalent bond formation, both the atoms contribute one electron each, and hence the shared pair of electrons are the pair of electrons are shared by both the atoms equally. But in certain cases, both the shared pair electrons are contributed by one atom and they shared by both the atoms. Such kind of bond formation is called coordinate covalent bond or dative bond. Okay, that is called coordinate covalent bond or dative bond. Next one. The shared pair of electrons which results in the bond formation are called bonded pair. The pair of electrons which are participating in the bond formation are called bond pair of electrons. And if there are pairs of electrons in the valence shell of the central atom, and if they are not participating in the bond formation, then they are called lone pair of electrons. If the pair of electrons, if they are shared in the covalent bond, if they are participating in the bond formation, then they are called bonded pair of electrons. Next one. Next, let us say about single correct answer type questions. See the first one. The number of valence electrons and the valency are equal for. So here two terms are there. One is valence electrons and valency. Valence electrons means the electrons present in the outermost shell of an atom. And valency means the combining capacity of an element. The number of electrons lost or gained or shared by an element to become stable is called its valency, and the number of electrons present in the last shell or outermost shell of an atom is called its valence electrons. Now if you see sulfur, its atomic number is 16, and if you write configuration for this, we get it as 2 comma 6 2 comma 8 comma 6. Now the number of electrons present in the outermost shell is 6, so valence electrons is 6, but its valence is 2 because it will be accepting 2 electrons in the bond formation, or it shares 2 pairs of electrons. So its valence is 2. Both are not equal. Now if you see silicon, its atomic number is 14, and if you write its configuration, we get it as 2 comma 8 comma 4. So it has 4 valence electrons because it has 4 electrons in its last shell, and its valency is 4 because it shares 4 pairs of electrons of the atoms. So covalence is 4. So valency and valence electrons both are same for silicon. Let us see other elements also. If we see phosphorus, its atomic number is 15 and configuration will be 2 comma 8 comma 5. So valence electrons is 5 and its valence will be 3. It shares 3 pairs of electrons and hence it gets octet. So both are not equal, isn't it? But if you see for chlorine, it has atomic number 17 and its configuration configuration will be 2 comma 8 comma 7. So number of valence electrons is 7, but its valence will be 1 because it will either accept one electron or it will share one pair of electrons. So its valence is 1. So valence electrons are not equal in case of chlorine also. Only in case of silicon it is true. It is equal. Okay. Next one. An atom A has 2 comma 8 comma m electrons. That means 2k electrons, 8 electrons, 3m electrons. Another atom B has 2 comma 6 electrons. That means 2 electrons in the first shell K shell and 6 electrons in the L shell. The formula of the compound formed between A and B is, what might be the formula of that compound? Let us see here first again about A. Its configuration we can say as 2 comma 8 comma 3. There are 3 electrons in its valence shell. To become stable, A will be always ready to lose these 3 electrons and forms A plus 3 ion. If we see in case of B, its atomic configuration is represented at 2 comma 6. So it has 6 electrons in its valence shell and it is ready to gain 2 electrons and forms a B minus 2 ion. Thus, the molecular formula of the compound formed between these two can be derived by using crisscross method like this. These two will come here and these three will be written here at the base of B. That becomes A2, B3. Okay, this is the molecular formula of the compound formed by A and B. Where it is A2B3, here it is. It is a correct answer. Okay, next one. An element X is strongly electropositive and an element Y is strongly electronegative. Both are univalent. The compound formed by their combination contains. So if X is being strongly electropositive and it is mentioned here, it is univalent. Means it is very ready to lose one electron and forms X plus ions. Whereas if you see Y is strong electronegative and it is also univalent. So Y will be always ready to gain one electron and forms F minus ion. So when these two combine together, they form ionic compound which is containing X plus and Y minus ions. Okay, because we cannot say here XY molecules because in the ionic compounds there is no existence of single molecule. There will be crystal of ionic substance which is containing oppositely charged ions held together with strong forces. So that contains oppositely charged ions of X plus and Y minus. So this will be correct answer. Okay. Next, fused ionic compounds. What is meant by fused ionic compounds? Molten. When ionic compounds are heated at very high temperatures, they convert into liquid state. These liquefied ionic compounds at very high temperature are called fused ionic compounds. In the fused state as well as in the in the aqueous state, ionic compounds split into their respective ions, and hence because of this presence of ions, they can conduct electricity. So in the fused state as well as in the aqueous state, ionic compounds conduct electricity. Okay, next one. Molecule which contains four bonded pairs and two lone pairs on the central atom is. There should be four bonded pairs and two lone pairs of electrons. See which molecule it is. We see xenon difluoride. We know xenon will be having totally 8 valence electrons. Let us consider 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 electrons, and it is bonding with two fluorine atoms. What happened here? Now we can say it has these two are bond pairs and these three comes under lone pairs. 1, 2, 3. 3 lone pairs and 1 and 2. 2 bond pairs. We can say 2 bond pairs and 3 lone pairs here. If we see in case of carbon dioxide molecule, central atom is carbon. It has 4 valence electrons and it is participating in the 2 covalent bonds with each oxygen atom. Isn't it? Now after the bond formation, how many bond pairs are there on the carbon atom? There are 4 bond pairs. And lone pairs? There are no lone pairs at all. So lone pairs number is 0 here. If we say xenon tetrafluoride, let us write that also here once. So xenon will be having 4 bond pairs of totally 8 electrons in its valence shell. Isn't it? So 1, 2, 3, 4, 5, 6, 8, okay, 7, 8. Okay, in this way, and it is participating in the bond formation with the 4 fluorine atoms. Let us represent like this those. Now if you see here, the number of lone pairs 1 and 2 and number of bond pairs 1, 2, 3, 4. So there are 4 bond pairs and 2 lone pairs on the central atom xenon after the bond formation here in the XeF4. What about SF6? Sulfur has 6 valence electrons and 6 are participating in the bond formation with the 6 fluorine atoms. Now we can say in this SF6 molecule, number of bond pairs is 6 and number of lone pairs is 0. Now if you see once again the question, the molecule with 4 bond pairs and 2 lone pairs on the central atom is xenon tetrafluoride. Okay, this is a molecule, right? Next one. Compound having maximum number of bonded pairs of electrons in its molecule. So maximum number of bond pairs of electrons in which it is there. If you see methane, methane molecular formula CH4 means central atom is carbon. It is bonded with 4 hydrogen atoms. Now how many bond pairs are there? 4 bond pairs, isn't it? 4 bond pairs are there in the methane molecule. If you see ammonia molecule, its molecular formula is NH3. Central atom is nitrogen. It is connected to 4 hydrogens and there is one lone pair of electrons on the nitrogen. Now number of bond pairs in the ammonia molecule is 3. If you see fluorine molecule, its molecular formula is F2. If you write the molecular formula of with Lewis dot structures, we know each fluorine will be having totally 7 valence electrons. Okay, it is bonded with one fluorine atom with other fluorine atom with one covalent bond. Now number of bond pairs is only 1. Number of bond pairs is 1 in this. If it's nitrogen molecule has a triple bond between the two nitrogen atoms already we have seen. So number of bond pairs is 3. So which molecule is having more number of bond pairs now? They're asking about especially bond pairs of electrons. So methane molecule is having 4 bond pairs. It has more. Next question. Which of the following conditions is favorable for covalent bond formation? What conditions favors the formation of a covalent bond? Atoms should have small size. It is correct. Then only instead of losing or gaining electrons, they share electrons. Atoms should be big sized. If they are big sized, they will be ready to lose electrons, not to share. Okay. Atoms should have high electronegativity. Then only they can share electrons. So these two are correct statements. Now what will be correct answer? A and C. Okay. Next one. Which of the following is covalent molecule? Covalent molecule means the molecule which is formed by the sharing or mutual sharing of mutual sharing of electrons between the atoms. See, in these all molecules, electrons are shared between the two atoms, hence these molecules are formed. In F2 molecule, one pair of electrons are shared. And in the Cl2 molecule also, one pair of electrons is shared between the two chlorine atoms. In the formation of water molecule also, two pairs of electrons are shared, one with each hydrogen. So this is also having covalent bonds. All the three molecules are having covalent bonds only. So what will be correct answer? All of these. Okay. Next one. Identify the molecular formula of carbon tetrachloride. In the name itself, it is a carbon. Carbon tetrachloride. So, two 4 chloride ions or 4 chlorine atoms combined with one carbon atom to form carbon tetrachloride. So, the molecular formula is CCl4. Here we can understand this tetra. Tetra represents 4. Carbon with 4 chlorine atoms, CCl4. Right? Next one. Which of the following is a covalent molecule? How to say whether it is a covalent molecule or a ionic compound? So here, if the bond or molecule, if it is formed between electropositive and electronegative atoms, then obviously it will be ionic compound. If it is formed between the atoms the same electronegativity or between the same atoms, then the molecule will be covalent molecule. If you see hydrogen molecule, here the bond is formed between same kind of two atoms, then there is no formation of ions or there is no transfer of electrons occurring. Just sharing of electrons takes place. The bond formed by the sharing of electrons is called covalent bond. So H2 molecule is a covalent molecule, whereas CaO, calcium oxide, potassium chloride, sodium sulfide, these all are ionic substances which are formed between two atoms with a greater electronegativity difference. If there is greater electronegativity difference, then transfer of electrons occurs, hence they form ionic compounds. Okay, next one. So here we did not mention also, it is CCl4. Okay, next one. Which of the following substances is not having covalent bonding? See, means which is not a covalent compound we have to see. As I told just now, if the bond formed between two atoms, the high electronegativity difference, then the bond will be ionic compound, ionic bond. If the atoms having electronegativity difference less, then the bond formed will be covalent bond. If you see sodium chloride, sodium and chlorine both are having high electronegativity difference. Thus, the bond formed between these two will be ionic bond, because here sodium loses electron, at the same time chlorine gains that electron. So here the bond formed by the transfer of electrons. Thus, it is said to be ionic bond, not a covalent bond. So it is ionic bond. If we see hydrogen chloride, copper chloride, ammonia, in these all bonds are formed between because of the sharing of electrons between them. So they are covalent bonds except sodium chloride, which is having ionic bond. Next one, which of the following has maximum number of lone pairs associated with xenon? So where more number of lone pairs of electrons present on the central atom xenon in this. So where there are less bond pairs, there will be more lone pairs on the central atom obviously. We see xenon difluoride. We know xenon will be having totally 8 electrons in its outermost shell. In that, 2 electrons are participating in the bond formation with 2 fluorine atoms. So now how many lone pairs of electrons are there? 3. So number of lone pairs on xenon is 3 here. Here number of bond pairs increased and hence number of lone pairs decreases. So simply we can say as number of bond pairs increasing in the central atom, number of lone pairs decreases. Let us see here xenon. Xenon is having 4 pairs of electrons, so we can say simply, or 8 electrons. So out of these 8 electrons, 2 electrons will participate in the covalent bond formation with oxygen atoms. Now only there is one lone pair of electrons on these. So here we can consider this as dative bond. Okay, only one lone pair of electrons is on this. In the xenon tetrafluoride, 4 electrons will participate in the covalent bond formation. Remaining 4 electrons, nothing but 2 pairs of electrons will be unbonded, which are called as 2 lone pairs. In the xenon hexafluoride, 6 electrons will participate in the bond formation. Remaining 2 electrons, nothing but 1 lone pair of electrons will be on the xenon. Now, xenon difluoride is having maximum of 3 lone pairs of electrons on the xenon. Okay, next one. Which of the following has coordinate covalent bond? So which molecules are having coordinate covalent bond? You see, HCl has only one covalent bond. Carbon dioxide has two double bonds between the carbon and oxygen atoms. Sodium chloride has ionic bonds. Ammonium ion is having a coordinate covalent bond or dative bond between ammonia molecule and H plus ion. So here dative bond is existing in the ammonium ion in this way. So ammonia donating a pair of electrons which are present on the central atom nitrogen to the H plus ion which is having vacant orbital. So in this way, between these two, a coordinate covalent bond or a dative bond is formed. Thus ammonia molecule and hydronium ion, H3O plus ion, some other molecules like sulfur dioxide, sulfur trioxide, the ozone molecule, these all are having coordinate covalent bond in them. Okay, this is about level 1 practice sheet. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.